This is the final video for Chapter 13, which is about integration. In the previous videos, we've looked at how we can use integration to reverse differentiation, how we can use integration to take the gradient function back to the original. We've looked at how we can use integration to find indefinite integrals, and that's where you have to have the plus c. And remember, you've got to have it in the form ax to the power n. We've looked at how we use integration to find the value of definite integrals, and remember the value of a definite integral can be positive, negative or zero. And we've looked at how we can use integration to find the area down from a curve down to the x-axis, and what happens when the curve or the area we're looking for dips below the x-axis, and how to make sure we don't make any silly mistakes. So this last video is just about area that's enclosed between curves, a curve and a line, or two curves. And you can see on the diagram 1 shows a curve and a line and a finite area between them, and you notice that the curve is on the top of the area and the line is underneath. And the second diagram shows two curves, and you've got the negative quadratic on top of the area and the positive quadratic on the bottom of the area. And that's quite important for the technique that we're going to use to find enclosed area. So here we've got an example, and it says the diagram shows the curve y equals the positive square root of x and the line x minus 2y equals 0. We need to find the coordinates of the points where the lines and the curve intersect, and we're going to use integration to find the shaded area. The first thing we need to look at is we've got our two lines, and if you notice we've got a curve and a line. The line is not in the form y equals mx plus c or y equals, and they have to be if we're going to use simultaneous equations. Part A says find the coordinates of the points where the line and the curve intersect. The key word there is intersect. That means we're going to be setting them equal to each other and solving them. And then it says use integration to find the shaded area. And if you look at the diagram, you can see that the curve is on top of the area that we're finding and the line is underneath, which is quite important for the technique that we are going to use. So the first thing we need to find the points of intersection. So we've got y equals the positive square root of x, and if you rearrange the line, you get y equals x divided by 2, or a half of x, or x over 2. We'll set those equal to each other, so we get the square root of x equals x over 2. Now I'm going to work to the right, but really we should work down. If we square both sides, we get that x equals x squared over 4. Multiply both sides by 4, you get 4x equals x squared. Therefore, x squared minus 4x equals 0. If you solve that quadratic, you get x equals 0 or x equals 4, and then substitute it back in, you get y equals 0 and y equals 2. So the two coordinates are 0, 0 and 4, 2. And that actually marries up with our diagram. You can see I'm just going to put these values on here. So that's 4. Right, the next thing we're going to do is part B. Now, on part B, we're going to use quite a quick technique, but it does have an advantage, because if any of your area is below the x-axis, if you split it into bits, that can make the question longer. If you do it this way, you will get an answer straight away. So we're going to integrate between 0 and 4, because those are our two x values. Now we want whatever's on top of the area. On top of the area is the square, is y equals root x. And then we're going to take away the line, but it must be in the form y equals, so it's y equals x over 2. Again, be careful. If your function contains more than one term, you've got to make sure that you put that in a bracket and apply your rules. Now you can see square root of x is not in a form that we can integrate, so we need to turn it into x to the half minus x over 2, and we are integrating that with respect to x. If we integrate that, and remember when we integrate, we're usually going to square brackets. If you integrate x to the half, you're going to get 2/3 x to the 3 over 2. And if you integrate x over 2, you're going to get x squared over 4. And that's between the limits of 0 and 4. I'm going to put the top limit in. Okay, I'm just going to work to the right again, but you really should work underneath. So we put the top limit in, so it's 2/3 of 4 to the power 3 over 2 minus 4 squared over 4. And if you put your bottom limit in, which is 0, because every term contains x, in this case you're going to get 0. You use your calculator then to work that out. You're going to get 4 over 3 square units. Okay, so you can see in this case we did the integral of it, and it was curve minus line with respect to x. Of course, if the line was on top, you'd do line minus curve. So let's have a look at another one. So this next one, and just it's handy that this one does have the line on top. So it says use integration to find the shaded area bounded by the curve y equals x squared plus 2 and the line y equals x plus 2. And you can see we've got the curve and we've got the line. And if you look at the diagram, you can see the lines on top. So the first thing we're going to do is we're going to find the point of intersection. Okay, so we're going to use simultaneous equations. So you've got y equals x squared plus 2 and y equals x plus 2. Therefore, x squared plus 2 equals x plus 2. X squared minus x equals 0. Therefore, x equals 0 or x equals 1. We don't need the y part because we've not been asked to find the coordinates to the point of intersection. We need to find the x values of the point of intersection. So I'm going to put that on my diagram. So you can see there's 0 and this one is 1. Okay, so we're now going to use the quick technique and notice the lines on top. So we're going to do the integral between our two x values, 0 and 1, and then it's line, and the line is x plus 2 minus the curve, which is x squared plus 2. And we are integrating with respect to x. If we just sort that out, we get the integral between 0 and 1, or 0 and 1, x minus x squared dx, and I like to use a nice bracket. If we then integrate that into our square brackets, we're going to get x squared over 2, or a half x squared, minus a third x cubed, or a half. It really doesn't matter. Between 0 and 1, we're going to put our top limit in. So it's 1 squared over 2 minus it's 1 cubed over 3. And then when the bottom limit goes in again, you get 0. And if you sort that out, you get a 6. And the answer is a 6 square unit. 1/6 of a square unit. Now, the other method is, I'm just going to show you on the diagram. Okay, if you integrated between 0 and 1 the curve, you would get the area I'm colouring in now in pink. And then you can see that the other area, and I'll highlight that if I can in a nice highlighted colour, is a trapezium. So you all know how to find the area of the trapezium. So if you did the area of the trapezium minus the pink stripy area, you would get a 6 square unit. Okay. So question 3, it says the diagram shows the finite area are bounded by the curve with equations y equals 4x minus x squared and the line y equals 3. The line cuts the curve at points A and B. find the coordinates of A and B and find the area of R. So first of all, we're going to find the coordinates of A and B, and that's just setting. So we've got y equals 4x minus x squared. We've got y equals 3. So 4x minus x squared equals 3. Therefore, x squared minus 4x plus 3 equals 0. Okay, when you solve that, therefore, when you solve that, you end up with 1 and x equals 3. Therefore, A must be the coordinate 1, 3, and B is the coordinate 3, 3. I'm just using the diagram to tell me which is A and which is B. We then need to do part B. So I'll have to do part B, and you can see it's curve on top of the area, line is underneath. So it's the integral between 1 and 3, and it's the curve, which is 4x minus x squared, and then minus 3 because that's y equals 3. I'm going to integrate that. So if we integrate 4x, we get 2x squared minus a third x cubed minus 3x. Top limit goes in, bottom limit goes in. Always a good idea to show that, the 1 and 3 on, simply because our examiner is looking for that as part of the marking process. Okay, it's usually says something along the lines of, if you put 1 in, you get 2 lots of 1 squared minus a third of 1 cubed minus 3 lots of 1. So the examiner's notes will say student has substituted top limit and bottom limit. 0 minus, and it's negative 4 over 3. So our final answer is 4/3 square units. Okay. Right. Now, the last bit we'll have a little look at. Now, this question is quite a challenging question. It says the diagram shows the graphs of y equals x bracket x minus 3 and y equals 2x. And what we are going to have to do, we have to find that area. Now, do notice it's not the complete area between the line and the curve. The bit of the curve that dips under the x-axis is not going to be included. So we need a process. So the first thing we need to do is we need to find A and B. We can see that it passes through the origin. We know it passes through the origin. So this is our process. I'm going to write it down. So number 1, okay, we're going to find this area. So find the area that looks like this. Right, it's the integral between 0 and B of line minus curve dx, and that will give us the area that looks like that. Okay, right. Part 2, we're then going to find the area that is below the x-axis, this one. So we're going to find this area. Remember, so if we do 0 to A of the curve, okay, and then we're going to, because this is below the x-axis, we're going to make it positive, and then we're going to add it on, or take it off. Right, so let's have a little look. So step 1, we need to find A and B. So let's jot these down. Okay, so we're going to find A. Right, so you've got y equals x bracket x minus 3. So that will lead, right, when you're on the x-axis, to x equals 0 and x equals 3. Therefore, you can see that B must be 3. Sorry, A must be 3. My apologies. Right, we're finding A. Right, we'll now find B. And again, same thing again. Okay, that is where x minus 3 and y equal 2x cross each other. Therefore, x squared minus 3x equals 2x. That leads to x squared minus 5x equals 0. If you solve that, x equals 0, x equals 5, therefore b must be 5. So you can see that a is 3 and b is 5, and we need those. Right, so if we look back at our point, we're going to find the whole area between the line and the curve first, so that we need the 0 and the 5. So that is the integral between 0 and 5, and it's line take curve, so it's 2x minus, and the curve is x squared minus 3x dx. So this gives you the, oops, let's read that out. Okay, the integral between 0 and 5 of 5x minus x squared dx. Okay, I'm going to integrate that, so we get 5x squared over 2 minus a third x cubed between the limits of 0 and 5. And if we do what we've been doing, I'm going to miss out this step, but that will give us an area of 125 over 6 square units. Okay, and that is, I'll draw it for you, is the bit that looks like that. That's that bit. Okay, there it is, just that little bit there. Right, we then need to find the bit that's underneath. So that's part 2. And again, I'm going to work to the right. So that's the integral between 0 and 3 of x squared minus 3x dx. Okay, so we're going to integrate that, so we get a third x cubed minus 3x squared over 2 between the limits of 0 and 3. And again, I'm not going to show you putting the limits in. You can all show me that. In an exam, you must show that step. That is very, very important. But when you do that, okay, you get minus 9 over 2. Now, of course, it's negative because it's below the x-axis. Therefore, this area is 9 over 2. And that area, I'll draw it in black because I've got my black pen out, is that bit. Okay. Therefore, the required area is 125 over 6 minus the 9 over 2, which ends up being 49 over 3 square units. And that is the final answer. Now again, you could have done it different ways by splitting things up, but it's always a good idea to try and do it as efficiently as possible. Now on your sheet, you've got an extension question, and if you look at the extension question, it says find the area A enclosed by the curves y equals negative x squared minus 4x minus 1 and y equals x squared plus 4x plus 3. And you can see that one of the problems is part of the area you're looking for dips below the x-axis. So if you do top curve minus bottom curve, that will give you the area by default, even though some of it is below. Okay, and I'll give you a little hint. The answer that you are looking for is 16 root 2 over 3. So you can do that extension question. Then you need to do exercise 13G and mixed exercise 13. And that is the end of the videos on integration.